Okay, let's unpack this. We've got quite a stack of sources here, and they're all pointing towards a really massive transformation happening right now in finance.
hmm Particularly in treasury and capital markets, it seems.
Exactly. We're talking about this shift driven by, tech like blockchain, tokenization, this whole Web3 space.
Right. And this deep dive is really custom tailored for you, the learner, to help you quickly get a handle on what's most important in all this material you've shared.
Absolutely. Think of this material as like a roadmap to understanding a pretty seismic shift. Finance, well, it's basically becoming code.
Yeah, that's a good way to put it. Our mission today is to cut through the complexity, pull out the really vital insights, and show you what this actually means on the ground.
For skills, for roles, for strategic thinking in finance.
Exactly. And here's where it gets, well, really interesting. It's not just about understanding the technology itself, is it?
No, it seems much deeper. It's about how the fundamental mechanics of finance change when, the rules are written in code.
And how key relationships adapt,
Mm.
and yeah, how even AI is going to play a pretty significant role in all this.
Okay, so how are we going to navigate this?
Well, I think we should start by getting a solid handle on the core building blocks, Web3, blockchain tokens, the basics.
Right. The foundations.
Then we'll explore how value and trust actually operate in this new digital architecture. It's different.
And finally, dive into the specific sort of concrete impacts on roles, like treasury and capital markets.
Precisely. Including how that future looks with AI layered on top.
All right, let's jump straight into the source material then and uncover those crucial nuggets for you.
Okay, so foundational stuff first. We keep hearing this term Web3. What is it, really?
Yeah, what's the core idea coming through in the sources?
The main thing is that it's seen as the next evolution of the internet. The design is meant to push power away from these huge centralized platforms.
Like the big tech companies we all use now.
Exactly. And shift that power towards decentralized networks built on blockchain technology.
So less power concentrated, more spread out.
Precisely. And at its heart are these key concepts, like uh, decentralization data isn't controlled by just one company.
Right.
It's about user ownership. You actually own your digital stuff, your identity, using things like crypto wallets and private keys.
Right, owning your own data, essentially.
Yeah, and tokenization comes in there too, using digital tokens to represent pretty much anything, money, art, access, you name it.
And smart contracts. I hear that term a lot.
Those are crucial. They're like self-executing agreements just written into code. If certain conditions are met, the contract automatically does what it's supposed to do.
Okay. And permissionless.
That means anyone can basically build on it or participate without needing to ask permission from some central gatekeeper.
That feels fundamentally different from, the internet we use every single day.
It really is.
Yeah.
I like how some of the sources use that city analogy to explain the difference.
Yeah, that was helpful. Web 1, the early internet. Like a library, right?
Yeah.
Mostly just reading information.
Yeah. Exactly. Very limited interaction. Then Web 2, where we are now, that's the big shopping mall.
You can do a lot. Interact, create, connect. But the mall owner, the big tech platforms, they ultimately own the space.
Right. They own your data, your connections, your content. It's all on their terms.
Yeah? So Web3 is?
The cooperative village. That's the idea. You own your house, your data, your digital assets. You carry your wallet, your digital identity, and funds with you everywhere.
And you can participate in governing the village, like decentralized decisions.
Potentially, yes. And if you create something valuable, you can earn directly from it without that mall owner taking a massive cut.
Okay, yeah, that analogy does help connect the dots quite a bit.
So when we look at the examples in the sources, we're talking about the underlying blockchains like Ethereum or Solana.
Right, the infrastructure layers.
Then things built on top, like Uniswap for decentralized trading, that's DeFi, decentralized finance, or NFT marketplaces like OpenSea.
Even new kinds of social media or browsers that use tokens.
Exactly. It opens up some really fascinating possibilities, like broader financial inclusion, potentially empowering creators more directly.
But there are downsides too, right? The sources mention risks.
Oh, absolutely. Things like scalability. Can these networks handle massive user numbers? Regulatory uncertainty is a huge one. And just the complexity for everyday users, it's still pretty high. Plus, scams are definitely an issue.
Okay. But the simple takeaway, the core idea.
Web3 is basically the internet being rebuilt with the goal of giving you actual digital ownership of your money, your data, your identity, without needing those big companies in the middle.
Got it. And underpinning a lot of this is blockchain. It feels like everyone talks about it, but what is it fundamentally? That village notebook analogy comes up again.
It does, and it's pretty effective. Imagine that village again, trading goods, instead of one central banker keeping the ledger.
Everyone keeps their own copy.
Exactly. Everyone in the village keeps a copy of this shared notebook. When Alice gives Bob 3 apples, everyone writes it down in their own notebook.
Okay, so the record is distributed. That makes sense.
Yes. And once they fill up a page with these transactions, and crucially, everyone agrees the page is accurate,
Then what?
that page gets, sealed and added to the stack of previous pages. You can't go back and secretly rip out a page or change something on an earlier page without everyone else knowing immediately because their copies wouldn't match.
Okay. And that stack of sealed pages linked together in order, that's the blockchain.
Precisely. Each block is a page of transactions, and they're chained together using cryptography, which makes them incredibly secure and tamper-proof.
So what makes it so special then, based on that analogy?
Well, it's decentralized. No single person or entity is in charge. No single point of failure. It's tamper-proof, like we said. Everything is time-stamped.
And it can be public or private?
Right. Some blockchains are open for anyone to see and audit. Others are restricted to specific participants, like maybe within a group of banks.
And this is the core ledger technology for Web3 and tokens.
It is. It's the system that proves this digital wallet now owns this specific token. When a token is transferred or a smart contract runs, the blockchain is that shared, unchangeable notebook recording the event.
It's like a digital receipt that can't be faked because everyone holds a copy.
Exactly. It's verified by potentially thousands of computers all agreeing. That's how you get trusted transactions without needing a traditional middleman like a bank or a lawyer sometimes.
Perfect. Okay, so we have Web3, the decentralized internet idea, blockchain, the trusted ledger, and tokenization, turning things into digital items on that ledger. Let's talk value. How does something like Bitcoin actually get its value?
Yeah, the sources point to supply and demand, but it feels more complex than just that sometimes.
It is, but supply and demand is absolutely the fundamental driver. Just like with, say, gold or maybe real estate, its value at any given moment is really just what buyers are willing to pay sellers for it.
And that happens on exchanges all over the world, right? There's no central price setter.
No, definitely not. No Federal Reserve for Bitcoin setting interest rates or anything like that. It's purely market-driven, 247.
Okay. And what influences that market price?
Well, a whole range of factors mentioned in the sources. Things like major news events, obviously. The known limited supply of Bitcoin is a big one.
The fact that there will only ever be 21 million.
Right. General public interest and hype, investor sentiment, those play a huge role. Regulatory news is massive if a country accepts it or bans it.
That makes sense. Technology and security updates, or conversely, hacks.
Definitely. And critically, just how widely it's being adopted and used. If more businesses start accepting it or more people start using it, that increases demand.
It's a bit like that digital real estate analogy again.
Yeah.
There's a fixed amount of land, and if more people want to build or live there, the price per plot goes up.
Yeah, it's a helpful way to frame it.
Yeah.
Which leads us nicely into Bitcoin's potential as a store of value, or SOVI.
Right. What makes something a good store of value, traditionally?
Well, the sources list a few key characteristics. It needs to reliably hold or, ideally, grow its value over time. It should be durable, last a long time.
Okay. Limited supply.
Limited or at least predictable supply is crucial. It needs to be generally accepted as valuable, hard to counterfeit or fake, and ideally relatively stable in value, at least over the long term.
Okay, so let's compare Bitcoin to traditional currencies like the US dollar or the Indian rupee, Canadian dollar, whatever. What really stands out based on those criteria?
The supply difference is probably the most stark. Bitcoin, hard, fixed cap of 21 million coins, written in the code. Traditional fiat currencies.
Well,
basically unlimited supply, right? Central banks can decide to print more whenever they deem necessary.
which means fiat is controlled by governments and central banks, whereas Bitcoin is controlled by its code and the consensus of its network participants.
Exactly. And that has huge implications for inflation risk. Bitcoin, with its fixed supply, has inherently low programmed inflation risk. Fiat can be inflated away if too much is printed.
Access is different too, isn't it?
Yeah, that's a big point. Anyone with an internet connection pretty much anywhere can potentially access and use Bitcoin. Traditional currencies often require access to local banks and are subject to national controls.
What about stability, though? Bitcoin's known for being volatile.
It is, especially short-term. Day-to-day fiat currencies are generally much more stable. But then you look at security. Bitcoin, if you secure your private keys properly, is incredibly hard to steal or seize remotely.
Whereas bank accounts can be frozen, physical cash can be stolen or devalued by government actions.
Right, and the trust model is fundamentally different. Trust in Bitcoin relies on the verifiable math and cryptography of the system. Trust in fiat relies on, well, trust in the government and the stability of the national economy backing it.
That comparison really highlights why some people call Bitcoin digital gold.
The parallels are pretty strong, aren't they? Gold is scarce, you can't just print more of it. It's seen as a long-term savings asset, but it can be cumbersome to store securely or move large amounts physically.
And Bitcoin.
Shares that program scarcity and maybe that long-term savings potential. But it's incredibly easy to store digitally. It just needs secure key management, and you can send vast amounts across the globe almost instantly. Plus, verifying its authenticity and transfer is fast and transparent on the blockchain.
So the sources seem to frame it as potentially a strong long-term store of value, particularly maybe against less stable national currencies, but they absolutely acknowledge the significant short-term price swings.
Definitely. Volatility is part of the current reality. And this connects to something really fascinating the sources emphasize, the role of math. It's not just involved in Bitcoin, it actually shapes its value and is the bedrock of its trust.
Math. How is math so central here? Seems counterintuitive for finance sometimes.
Well, because the entire system, its rules, its security, its supply, is built on and enforced by mathematical algorithms and cryptography. It's not based on promises or policies. It's based on code that executes mathematical functions.
Okay, tell me more. Like the math behind the scarcity.
That 21 million coin limit, it's not just a guideline. It's mathematically enforced by the software protocol. Humans can't just vote to change it and print more easily. This predictable absolute scarcity, guaranteed by math, is a core part of its value proposition, similar to why gold is valuable.
And the mining process.
Huh.
That proof of work thing involves math too, right?
Complex math problems, yeah. Miners use immense computing power to solve these cryptographic puzzles. This mathematical work does two things. It secures the network by making it incredibly expensive to attack, and it validates transactions, bundling them into new blocks for the chain.
So it takes real effort, like digging gold out of the ground. There's a cost of creation.
Kind of, yeah. And the math automatically adjusts the difficulty of these puzzles based on how much computing power is on the network. This controls the rate at which new Bitcoin is created and released, making it predictable.
And the halving. That's purely mathematical too.
Totally. The reward miners get for adding a block is cut in half roughly every 4 years, following a strict algorithmic schedule embedded in the code. It went from 50 to 25, 12.5, 6.25, now 3.125 Bitcoin per block.
And this mathematically slows down the introduction of new supply over time.
Exactly. It ensures that the 21 million limit is approached gradually and predictably. This programmed reduction in new supply, often happening against potentially stable or rising demand, is seen as a key driver of Bitcoin's long-term price cycles.
Okay. And the security of my individual Bitcoin holdings, my wallet, that's math too.
Absolutely. Advanced cryptographic math, things like public key cryptography and digital signatures, ensures that only the person holding the correct private key can access and spend the Bitcoin associated with a public address. It also ensures transactions, once confirmed, can't be altered.
So the trust isn't in a bank or a person. It's in the mathematical principles being correctly applied by the code. Principles anyone can verify.
Precisely. Math that theoretically can't lie or be easily corrupted, unlike human intermediaries sometimes. And then, of course, the actual market price itself is ultimately the result of the math of supply and demand playing out on exchanges.
Wow. So when you break it down, math provides the verifiable trust, the security, the absolute scarcity, and the predictable supply schedule. It governs the whole system and is fundamental to why it has value.
So just to hammer this home, the sources absolutely confirm that 21 million coin limit is a hard, unchangeable cap baked into the system's math.
That is the core design principle, yes. The code dictates that mining rewards decrease over time through the halvings until they eventually become effectively zero, which is estimated to happen around the year 2140.
And at that point, the total number of Bitcoins in circulation will stop increasing, maxing out precisely at 21 million.
Correct. It's mathematically enforced scarcity designed from the start.
Okay, that gives us a really solid grasp on the technology and how value works within it. Now, let's shift gears. What does all this actually mean for professionals working in finance today, specifically in treasury and capital markets roles?
Yeah, the sources are pretty clear on this. This whole transformation isn't just interesting theory. It demands new, very specific skill sets for treasury folks.
It's not just business as usual with some new software then.
Not at all. The traditional treasury role is being fundamentally reshaped. The sources actually lay out 10 key skills that are becoming essential.
10. Wow. Okay, maybe walk us through some of the most critical ones that really stand out.
Sure. Well, beyond the core finance expertise you'd expect, you need things like, number one, smart contract fluency.
Fluency. Does that mean coding?
Not necessarily writing complex code from scratch, no,
Yeah.
but understanding the logic of smart contracts. If your company issues a digital bond or sets up automated payments on chain, you need to grasp how that contract works.
So being able to read or at least review the logic, understand the rules.
Exactly. And understanding how things like compliance rules, KYC/AML checks, investor eligibility can be embedded directly into the contract and automated.
Okay, understanding the automated rule book. That makes sense. What else?
Then there's blockchain workflow familiarity. This is more practical, hands-on stuff, knowing how to actually use the platforms that issue or manage these digital assets.
Like specific software.
Yeah, platforms like Securitized, Tokenized, Fireblocks come up. It also means managing digital wallets securely, a huge responsibility, and being able to use block explorers like Etherscan for Ethereum to actually track transactions and see what's happening on the public ledger.
It sounds a bit like learning a new, very transparent accounting system almost.
In a way, yeah, but it runs on distributed consensus. Another really critical one is on-chain liquidity and risk analysis. This is about using real-time data.
Not waiting for month-end reports.
Right. Using dashboards, possibly tapping into specialized DeFi analytics platforms like Dune or Nansen to monitor your company's tokenized assets, manage cash positions instantly, and importantly, understand the new kinds of risks.
Like what?
Like smart contract bugs or risks related to oracles, the external data feeds that smart contracts sometimes rely on. If the price feed is wrong, the contract might execute incorrectly.
Okay. API and platform integration know-how sounds familiar from modern finance, but I guess it's different here.
It's about connecting your traditional treasury systems, your ERP, your TMS, directly to these new blockchain platforms and potentially automating complex workflows like cash sweeps or disbursements via APIs.
Got it. And digital compliance operations must be huge.
Massive. Understanding how compliance is shifting from manual processes and checks to being automated and enforced directly on-chain. Things like executing KYC/AML through software plugins linked to wallets or managing whitelists of approved investors coded into the asset itself. You need to oversee and audit this automated compliance.
Okay, that's 5. What about the more analytical side?
Yeah. Then you get into skills like data modeling and simulation, being able to model the behavior of these new tokenized instruments, maybe using tools like Python or SQL, running stress tests on how they perform under different market conditions.
And treasury product structuring and code. That sounds very new.
It is. It means collaborating closely with legal teams and engineers to translate traditional financial features like amortization schedules, interest payments, call options on a bond into the actual logic of a smart contract.
So finance pros helping design the code itself.
Essentially, yes. Then there's cybersecurity awareness, which is absolutely non-negotiable when dealing with digital assets.
Managing wallets, keys.
Exactly. Understanding wallet permissions, multi-signature controls for security, cold storage versus hot wallets, evaluating the security risks of different protocols, preventing phishing and other exploits. The threat landscape is different.
Makes sense. What else? 2 more.
Interoperability and network awareness. Knowing that there isn't just one blockchain. Understanding the differences and use cases between networks like Ethereum versus maybe Avalanche versus private chains like Corda, and understanding how assets or data might move between them using bridges or where reliable stablecoins come from.
Okay, knowing the landscape. And the last one.
Decision-making with real-time data. This ties back to the liquidity analysis point. It's about fundamentally shifting away from relying on periodic, batch-processed reports and spreadsheets.
To using live, on-chain data streams.
Yes, using live dashboards to make critical treasury decisions instantly. Things like allocating cash, timing debt issuance, executing FX hedges based on real-time market conditions reflected on-chain. It's a big technological and mindset shift.
That is a significant layer of tech skills on top of the traditional treasury role. It's quite a list.
It is. And interestingly, the sources don't just talk about current treasury pros needing these skills. They also identify certain existing tech backgrounds that are surprisingly well positioned to transition into these evolving treasury roles.
So people who aren't currently working in treasury might actually be a good fit.
Exactly. Think about folks like API integration engineers or maybe fintech product developers. They already live and breathe real-time data, connecting systems, designing automated workflows.
So they can move into.
Roles like a tokenized treasury integration architect or an on-chain treasury operations lead. They understand the plumbing already.
Okay. Who else? Data analysts or BI developers seem like a natural fit too.
Definitely. People skilled in building dashboards, running complex models, maybe using Python or SQL for analysis. They could transition into liquidity analytics strategist or digital risk and ALM analyst roles. They get the data side.
And actual blockchain developers, the ones already building this stuff.
They're almost plug and play for certain roles. They understand smart contracts, tokens, on-chain compliance already. They could become a tokenized debt engineer or a smart contract structuring advisor, directly building or advising on the financial instruments.
Okay. Cybersecurity analysts seem obvious for security roles.
Right. Like a treasury security officer focused specifically on digital assets, or an on-chain risk controls lead, designing the safeguards. They understand wallet security, vulnerabilities, threat detection.
And what about people already working in the Web3 space, but maybe not in traditional finance?
Yeah, Web3 DeFi operations professionals. People comfortable using tools like MetaMask wallets, Etherscan, maybe DeFi dashboards like Dune Analytics Daily. They understand the on-chain environment.
They could become.
A digital treasury operator managing the day-to-day on-chain activities, or a token liquidity strategist figuring out how to ensure tokenized assets can be easily traded.
And treasury tech consultants or people who implement ERP/TMS systems today.
They're also well-positioned. They understand the current treasury pain points and how technology is already being used. They could pivot to roles like digital treasury transformation lead or tokenized finance consultant.
Makes sense. They bridge the old and new worlds.
Right. And the sources even toss in a bonus category: AI plus RPA workflow designers. People expert in automating tasks using artificial intelligence or robotic process automation.
How do they fit in?
As more treasury processes get automated via smart contracts and APIs, their skills in designing, optimizing, and managing complex automated workflows become incredibly valuable. Think AI-enabled treasury ops designer or smart agent workflow orchestrator.
It's fascinating. It suggests that the talent pool for the future treasury function might look very different. It might be easier for these tech folks to learn the finance context.
Then for traditional finance pros to gain that deep hands-on tech fluency. Which brings us right to the core question. Why is it so critical? Why must current treasury professionals actively pivot and gain this tech understanding?
It sounds like more than just staying competitive.
It's really presented as existential in the sources. The fundamental reason is finance is becoming code. Core treasury functions, managing cash flow, issuing debt, handling payments, ensuring compliance, are increasingly going to be governed by these self-executing smart contracts.
And if you don't understand the code,
You can't effectively supervise it, you can't optimize it, you can't even properly assess the risks or identify if something is going wrong. The old mindset was about manually executing a process. The new mindset has to be about understanding how the automated system executes itself and knowing how to design, monitor, and influence that system.
so tech isn't just a back office support function anymore for treasury.
Not at all. It's moving front and center, shaping strategy. APIs, blockchain platforms, digital asset tools, these are becoming core front office capabilities. The professionals who understand them and can leverage them strategically are the ones who will lead the transformation.
And the risk of not adapting.
The sources are quite blunt. They warn that tech-illiterate professionals risk being delegated out of relevance. As tokenization, AI, and DeFi increasingly integrate into corporate finance, if you only understand the traditional way, the decisions and oversight will shift to those who understand the new digital rails. Future leaders need to grasp both the capital logic and the underlying code and infrastructure.
Okay, the message is clear. But it doesn't mean everyone needs to become a hardcore software engineer, right?
No, definitely not. The goal is to become that finance X-tech hybrid. Someone who deeply understands the financial goals and processes, but also has fluency in the technology enabling them.
So how can current treasury pros make that pivot? What specific skills should they focus on building?
The sources suggest focusing on areas directly applicable to finance roles rather than general coding. For instance, learning the basics of smart contracts, maybe focusing on understanding solidity concepts, common token standards like ERC20 could prepare you for a role like a tokenized debt structuring lead. You're bridging finance needs with code capabilities.
Okay. What about APIs and automation?
Understanding how REST APIs work, how different systems connect, how to automate workflows between your TMS and, say, a digital custody platform, that builds towards a Treasury API integration manager role.
And the data side, using those on-chain tools.
Exactly. Getting comfortable with block explorers, learning basic query skills on platforms like Dune Analytics, maybe building simple dashboards. That path leads towards a digital liquidity analyst.
What about actually using the new platforms?
Getting hands-on experience operating institutional tools like Fireblocks, Tokeny, or Securitize. Understanding wallet management, custody solutions, the operational flow, that builds skills for a digital treasury operator.
And the crucial risk and compliance angle.
Focusing on digital asset cybersecurity, best practices, wallet security, permissions, multi-sig setups, and understanding how KYC-AML and other regulations are being automated on-chain. That points towards a smart contract risk and compliance analyst role.
So how does this look in practice? Is it about going back to school?
Not necessarily. The sources suggest it's more about embedding this learning in your current work, maybe shadowing tech teams on projects, actively volunteering for digital transformation initiatives or tokenization pilots, even small ones.
Building that tech muscle incrementally.
Yes. Co-owning digital functions, getting involved in cross-functional teams with finance, legal, and engineering. It's about gaining practical exposure and starting to speak the language.
There's a final thought from the sources on this that really stood out.
Yeah.
It said the best positioned finance professionals in, say, 2030 won't just understand the financial objective. They'll also understand how the smart contract or the API actually makes it happen. That this pivot into tech fluency isn't just nice to have, it's basically about survival and staying relevant.
It's a powerful message. Let's make this even more concrete. Take a specific role, the primary placement manager, the person who helps companies issue new bonds into the market.
Right. Does tokenization just automate their job away completely?
The sources say definitively, no. But it fundamentally changes what they do and how they add value.
Okay. So the traditional role involves a lot of coordination, right? With investors, legal teams, compliance, other banks in the syndicate.
Exactly. Managing the book building process, negotiating pricing, allocating bonds, historically relying heavily on phone calls, emails, spreadsheets, maybe Bloomberg terminals. Trust and relationships are critical, especially for complex deals.
So how does tokenization change those specific process elements?
Let's bring it down. Investor onboarding. Traditionally, manual paperwork, checks. In a tokenized world, it can become automated via smart contracts that instantly verify if an investor's wallet address is on a pre-approved whitelist.
Okay, much faster. What about allocation? Deciding who gets how many bonds?
That shifts from manual negotiation and judgment calls, especially for simpler deals, towards potentially on-chain logic. The smart contract itself might execute allocation based on predefined rules, first come, first serve for whitelisted addresses, pro rata, etc.
And settlement. Getting the bonds to the buyer and the cash to the issuer.
That's a huge change. Instead of taking 2 days or more, T+2, and involving multiple custodians and intermediaries, tokenization enables potentially instantaneous T+0 atomic settlement. Yeah. The bond token and the payment token, like a stablecoin or maybe a future CBDC, swaps simultaneously via the smart contract.
Wow, okay. Compliance checks.
Moves from being primarily human-led, manual reviews, often post-trade, to being automatically enforced by the smart contract pre-trade or at the point of trade. The code itself checks eligibility based on the embedded rules.
And distribution. Reaching investors.
Can shift from relying on curated distribution lists and personal contacts to potentially global 247 programmable distribution, again, with rule sets embedded in the code, determining who is eligible to participate from anywhere in the world.
So given all that automation, what parts of the traditional placement manager role genuinely get reduced or maybe even eliminated?
A lot of the purely manual coordination for standardized plain vanilla bond issuances, that gets replaced by the automated platform and smart contract rules. The endless back and forth via email or phone for routine pricing and allocation updates diminishes significantly for simpler deals.
And the need for lots of intermediaries.
Yes, particularly for cross-border distribution. Tokenized platforms can allow issuers to potentially reach global investors more directly, reducing reliance on layers of intermediary banks in different regions.
Okay, so the repetitive process-heavy work gets streamlined. But human interaction doesn't vanish.
No, it becomes arguably even more critical, but it shifts focus. Strategic investor relationship management is still vital, especially for complex deals, high-yield bonds, or building long-term partnerships. You still need trust, persuasion, understanding investor needs deeply. The role moves from executing based on relationships to strategically nurturing relationships and then orchestrating the digital process.
And designing the deals themselves.
Structured deal engineering becomes even more important. Designing complex tokenized bonds with bespoke features, different tranches, callable options, embedded ESG compliance logic requires deep financial creativity and negotiation skills, even if the back-end mechanics are digitized. The human adds value in the design.
What about the really big investors, the anchor tenants?
Large anchor investor negotiation is unlikely to go away. Major institutions might still demand custom terms, specific covenants, or direct dialogue with the issuer's senior management before committing significant capital, even if the final settlement happens via tokens.
So the net impact seems to be less manual execution, more platform management, less operational relationship stuff, more purely strategic relationship building. Compliance is code-driven but needs human oversight. Investor access is automated via whitelisting. Pricing and allocation become more about designing and influencing the rules-based logic.
That's a great summary. The sources use a nice line. Tokenization automates the pipes, not the people. It reduces the need for manual coordination, but elevates the need for human judgment, strategic thinking, sophisticated deal structuring, and high-level relationship building.
The placement manager becomes less of a paper pusher, more of a digital deal architect and network orchestrator.
Exactly. Structuring smart, digitally native deals, orchestrating issuance through these new platforms, and focusing on building and maintaining those crucial, long-term, high-level investor networks.
And this ties into that point about the shift in relationship hierarchy. The sources suggest the important human interaction actually moves upstream.
Yes, that's a key insight. For the more standardized tokenized deals, the need for a direct personal relationship between the mid-level placement specialist and every single potential buyer decreases because the platform handles eligibility, rules, and execution efficiently.
So where does the crucial relationship layer reside now?
It moves higher up the organizational chart to the senior strategic decision makers. We're talking CFOs, treasury heads at the issuing company, chief investment officers or lead partners at the big investment firms, and private equity VC funds.
Why does that shift happen?
Because for plain vanilla bonds, the platform itself is the efficient distribution channel. The value proposition isn't a personalized sales pitch. It's the speed, transparency, and potential cost savings of the tokenized process. Investors trust the platform's rules for execution.
But the big anchor investors still want that strategic connection.
Right. They aren't just buying a standard bond. They might be making a strategic investment in the company. They want access, maybe preferred terms, direct dialogue about the issuer's strategy, governance, or ESG performance. Those high-level strategic alignment conversations happen between senior leaders.
And is part of this also about building trust in the technology itself?
Definitely. In a tokenized system, trust isn't just in the counterparty institution or the individual salesperson. It's also fundamentally about trust in the underlying blockchain's integrity and the logic of the smart contracts governing the asset.
So investors need confidence in the system.
Yes, and ensuring that confidence, explaining the security and logic, often requires engagement at a more senior strategic level. For the mid-level professional, the pivot is away from relying solely on their personal Rolodex for execution towards understanding how to structure deals and leverage digital platforms in a way that builds trust through transparent code and process.
Okay, so let's synthesize all this. What's a realistic, maybe even ideal, transition path for a current finance process? Let's stick with the debt syndicator example who wants to really thrive in this tokenized future.
The sources outline a pretty practical step-by-step journey. You start with their current position. Debt syndicator, primary market placement specialist. Their existing strengths are crucial understanding deal structuring, investor needs, market dynamics, compliance documentation like KY-CAML.
Right, leverage the existing finance knowledge. Then comes the key pivot point, the bridge role.
Exactly. This is envisioned as a targeted, maybe 2-3 year period focused on gaining specific tech fluency within a relevant context. Ideal bridge roles mentioned include being a business analyst within a fintech company or maybe a bank's treasury technology division.
Or a digital issuance product analyst.
Yes, someone helping define the requirements for these new tokenization platforms. Or even an IT project manager who is specifically overseeing the implementation of new treasury or capital markets platforms.
And why are these roles considered good bridges?
Because they force you to get hands-on with the technology and processes, but typically without requiring you to be a hardcore coder initially. You're collaborating daily with engineers, translating financial requirements into technical specifications, user stories, or API designs.
You learn how the platforms actually work under the hood.
Precisely. You gain practical understanding of digital issuance workflows, smart contract functionalities, maybe even things like agile development methodologies used in tech teams. You learn about API integrations between custody, issuance platforms, and core banking systems. You start understanding how financial logic gets encoded.
So during this bridge phase, they'd naturally acquire many of those 10 essential skills we talked about earlier.
That's the idea. Understanding digital workflows, maybe getting comfortable with agile sprints, grasping API connections, learning how on-chain logic works for things like interest payments or allocations, mastering the operations of specific platforms.
And they do this while retaining their valuable finance and market expertise.
Correct. They're not starting from scratch. They're layering tech fluency onto their existing financial foundation. After successfully navigating this bridge period, they are then ideally positioned for those future high-value roles. Roles like digital syndication lead, orchestrating deals on platforms, tokenized capital markets product manager, designing new digital assets, smart contract structuring specialist, advising on coding financial logic, or a senior treasury tech strategist guiding the overall digital transformation.
And could an internal move work too, like rotating into a bank's dedicated digital assets group or a treasury tech innovation team?
Oh, absolutely. The sources mention that counts too. The key is getting that embedded, practical experience where finance and technology intersect directly. It builds that essential, rare hybrid skill set.
It really paints a picture of a deliberate path towards becoming indispensable, doesn't it? Someone who truly understands both the what, the financial goal, and the how, the digital machinery.
That's definitely the strategic advantage highlighted. Now let's push the boundary a bit further. Let's look at the future landscape and bring AI into the picture.
Okay. Specifically, how might things like large language models, LLMs, and these powerful no-code or low-code development tools impact that role we just defined, the tokenization financial engineer?
First, maybe let's quickly reestablish what that role entails.
Right, the tokenization financial engineer.
The sources portray this as that new hybrid professional, someone combining deep financial product expertise with a solid technical understanding of blockchain, smart contracts, APIs, and the skill to orchestrate the complex end-to-end digital processes for things like issuing and managing tokenized assets. They're the architects of these new digital capital market pipelines.
Okay, the modern capital markets engineer. Got it. Now, introduce the disruptors. LLMs like ChatGPT, Claude, Google's Gemini, Microsoft's Copilot, and these no-code, low-code tools, things like DAML, maybe Tokenized Studio, Zapier for workflows, Bubble for apps.
Right. These tools are fundamentally democratizing access to capabilities that previously required specialized technical skills.
How specifically do they change the job of that tokenization financial engineer?
Let's compare before and after. Before, authoring a complex smart contract for a bond might require deep expertise in a language like Solidity. After, an LLM might auto-generate significant portions of that code based on plain English prompts, drastically reducing reliance on specialized developers for initial drafts.
Okay, faster prototyping maybe?
Potentially much more than that. Compliance logic. Before, it might be hard-coded by developers. After, low-code platforms might allow financial analysts or compliance officers to build sophisticated rule sets using visual, drag-and-drop interfaces, making it faster, more transparent, and easier to audit.
Interesting. What about orchestrating the whole workflow, connecting different systems?
After, often involved custom API scripting and integration work. After, LLM-assisted no-code binders could allow the engineer to define the workflow logic, and the tool generates the connections or API calls, shifting the focus from coding to high-level design and testing.
Data visualization.
Before, might require specific BI tools and expertise. After, you could potentially prompt an AI to auto-generate interactive dashboards and reports directly from on-chain or off-chain data sources.
Even complex things like investor onboarding.
Potentially.
Right.
Before, manual integration work. After,
Huh.
LLMs could help design and even build user-friendly onboarding flows using plug-and-play components, enabling more self-service for investors at scale. Documentation and reporting could also be largely AI-generated.
So if AI and these tools handle more of the coding and configuration, does the engineer role disappear?
Not according to the sources. It evolves significantly. The focus shifts away from the low-level how, writing specific code lines, and towards the high-level what and why, meaning their primary tasks become designing the intricate logic flows within low-code environments, writing very high-quality, precise prompts to guide the AI effectively, managing the interoperability between different AI-generated components or platforms. Critically, embedding and verifying regulatory compliance within these automated systems and overseeing the sophisticated risk modeling and liquidity simulations for these digital ecosystems.
So they transition from being a hands-on builder to more of a financial architect, overseeing the AI tools.
That's an excellent way to frame it. They need to speak the language of workflows, system design, risk parameters, and compliance rules, perhaps more than the language of specific code. The core strategic skill set shifts
From things like mastering Solidity or Python scripting.
towards emerging skills like prompt engineering, getting the best output from AI, AI-augmented system design, complex workflow orchestration across multiple platforms, and designing for resilience and compliance in an AI-driven environment.
What's the future outlook then?
The sources suggest LLMs and no code will level the playing field. More finance professionals, not just dedicated engineers, will be able to participate directly in building and customizing tokenized financial products and workflows.
And the engineers themselves.
Their role becomes more elevated, focusing on system-level thinking, governance, setting standards, running advanced simulations, and designing the overall compliance and security architecture. Smaller, more agile teams might be able to launch sophisticated digital asset products much faster than before. The job becomes less about building, more about governing, simulating, and designing the intelligent framework.
Okay, so putting it in one sentence, LLMs and no-code tools elevate the tokenization financial engineer's role from primarily coding and configuring to architecting and overseeing compliant, scalable, and increasingly intelligent digital asset ecosystems, using AI as a powerful toolkit.
That captures the essence of the transformation perfectly.
Wow. We have certainly covered a huge amount of ground in this deep dive. It's been quite a journey.
It really has. We started with those fundamental building blocks, Web3, blockchain tokens, making sure we had a good grasp of the basics.
Right. Then we dug into how value and trust actually work in this new world, seeing how they're uniquely rooted in math and market dynamics, especially using Bitcoin as an example.
And then we spent a good chunk of time looking at the real-world impact, how these technologies are fundamentally reshaping roles and demanding entirely new skill sets, particularly in areas like treasury and capital markets.
We looked at the specific skills needed, who might be well-positioned to transition into these roles, and why that pivot towards tech fluency is so critical for current finance pros.
And we even took a peek into the future, considering how AI and tools like LLMs and no-code platforms will likely further evolve these roles, shifting the focus towards architecture and oversight.
So the key takeaway for you, our listener, really seems undeniable after walking through all this material.
It feels pretty clear, doesn't it? This isn't just theoretical, far-off stuff anymore. It's actively impacting the day-to-day requirements, the necessary skills, and the long-term career paths for finance professionals now.
And adapting isn't about completely jumping ship from finance to tech.
No, it's about becoming that crucial finance x tech hybrid. You need to deeply understand the financial objectives, market dynamics, the risks, and you need fluency in the digital infrastructure, the code, the platforms that are increasingly making it all happen.
You know, thinking back to that section on how math provides this transparent, unchangeable foundation of trust in systems like Bitcoin and blockchain, it really sparks a final thought for me.
Yeah. What are you thinking?
Well, if we accept that principle that mathematically enforced rules and transparency can create trust algorithmically, where else could we apply that?
Beyond just finance, or within finance, but in different areas.
Both, maybe. Where else in our financial system, or even in other complex systems with intermediaries and potential opacity, could we leverage this idea of transparent, algorithmically enforced trust to reduce reliance on fallible human judgment or black box systems? It feels like a really powerful concept with potentially vast implications we haven't fully explored yet.
That's a really compelling question to leave our listeners with. Where else can verifiable code replace opaque processes to build trust? A lot to think about there.
Indeed. Well, thanks for joining us on this deep dive through the sources.